Thanks everyone for joining today for CakeFest and tuning in. This isn't how we've done it in the past, but you know, we're going to make the best of a bad situation. I'm sorry I'm not going to be able to make cake for everybody, but yeah, it'll be different but good. And today I wanted to talk about dependency injection and how that's worked out in CakePHP. So, like you've probably heard of dependency injection in the past, and I'm hoping to give you something new. I'm hoping you're going to walk away from this talk or turn around from your chair in this talk with a few things that you may not have known before. So namely, like understanding what dependency injection is, kind of some of the few patterns to achieve it, kind of know how CakePHP does dependency injection internally and how it's historically done it, and then also kind of like what's coming up next. But before we get too deep into like what dependency injection is, I want to be like clear on what it is and what it isn't. So we'll start off with like a big definition. So Wikipedia says that dependency injection is a technique in which an object receives other objects that it depends on. These other objects are called dependencies. In a typical using relationship, the receiving object is called a class, the injected object is called a service. Okay, yeah, so crystal clear, right? The article goes on like quite a bit longer. You should read if you really want to know how it all works. I'm going to kind of summarize and provide some like CakePHP context today. But the Wikipedia article is great. There's also a ton of other articles that you should look at. So while dependency injection can be fabulously complicated, as that Wikipedia article kind of alluded to, it doesn't have to be. If we boil dependency injection down into its simplest form, we end up with constructors. Constructors are the simplest and most straightforward way to do dependency injection. So if you think of constructors, they kind of take dependencies into an object and then allow your object to hold on to them. This like separates the construction of objects from each other and makes it so that your objects don't have to reach out into global scope and grab stuff and pull them inside, right? So your dependencies get passed in as constructors. Parameters are another form of dependency injection. So parameters get passed into your objects and they are injected, right? So injection just is like a fancy word for having something passed in. So setters are another way to do dependency injection. I'm not a big fan of setters because it allows your objects to be in potentially invalid states and you have to do a lot of null checks. So I bias heavily towards like constructor parameters just because I feel like they're a lot simpler. So the benefits of this dependency injection is that each object doesn't need to know about all of its collaborators and how all of those collaborators are created. This gives you flexibility now and in the future. You could swap this Stripe client with a different one, or one that reads responses from disk, or like, you know, is a mock. This becomes important when you're dealing with like mail or network objects or things that have to like talk to external services. Makes it easier to do tests, makes it easier to run simulations. Yeah, that's kind of some of the benefits you get. So if constructors are dependency injection, then why are there so many design patterns around this, and why is there so many like tools and systems around this? Constructors are pretty straightforward and simple. The answer is that real projects are complicated. I think a Netflix service, it looks like some sort of Death Star. It looks scary. Real projects are complicated and messy. Building objects every time you need them could work, but it leads to a lot of redundant and repetitive code. And that duplicated construction logic gets really fragile and tedious to maintain, as you kind of have to like find all the places you constructed an object and all of its dependencies. And then there's like big dependency chains, and then it all just gets really, really messy. So some of the design patterns around dependency injection allow you to consolidate that code and put it all into one place so that you can change it all in one place, and kind of also reduce the number of definitions, the number of times you define an object and its dependencies. So some of the patterns I'm going to talk about today, well, these are patterns I'm going to talk about today. They all assist with dependency injection and provide different ways to encapsulate object creation. And they all offer like different levels of abstraction and have specific use cases. So we're going to go like top to bottom and talk about them. Okay, so factories. If an object doesn't know how to create all of its dependencies, then you often need an object to create other objects, and these are called factories. Factories can make specific variations of an object type based on the provided inputs. So they make one thing really well, right? An example would be like a shape factory or a pizza factory. The shape factory takes a color and then can make shapes of a given color. So it can make a 3-sided shape or a 4-sided shape or a 5-sided shape. So some of the variation is captured inside the factory, and then takes parameters and then can cook up recipes based on that. Factories are great when you have a small number of variations and you don't need a ton of flexibility in how things are made. And also you don't mind hard coding the relationship between the factory and the thing that it makes. So factories are a great pattern, but they have they're small and focused on specific things. So next up are kind of like locators and registries. Locators and registries are related patterns. They both enable you to store objects with given names and then get the matching instance back. Generally, they let you like set or get instances, but registries are a little different from locators in that registries will often like create their objects on the fly and then store them and let you get them. Locators are often misused, and yeah, we'll talk about them in a sec. CakePHP uses registries extensively. We use them in caching and logging, components, behaviors, tables, helpers, basically all over the place. You define configuration for objects, and then a registry contains like family-specific logic that lazily creates registry, like the objects as you go. So in that first line, we create a log registry with some configuration, and then you tell that you can ask the registry, like, give me the default logger, and it will give you the logger. One thing that's nice about registries, or that's different about registries from factories, is that registries will give you the same object back every single time. So the first time you call a get for a specific name, it'll give you an object. The second time you call it, you'll get a different object. You'll get the same object. Whereas with a factory, you would get different objects each time. So you would call logger the first time, you'd get an object. If it was a factory, you'd call logger, you say get again, it would give you a new object. This is fine for like simple objects, but for really complex objects with deep dependence graphs, you don't really want to take the cost of like building those objects over and over again. So registries are good for shared resources or object graphs that contain cycles. Registries can resolve cyclic dependencies, which are harder to do inside of factory situations. Registries are also well suited for like families of objects that have a similar purpose or implement consistent interfaces. Trying to make a generalized registry ends up turning into like a, not generalized registry, a generalized locator where you can just put an object and then pull it back out later. Basically turns into like a very elaborate global variable. If you think of the globals keyword in PHP, it is theoretically a service locator. You can have symbols like names, like you can put a name in globals and you can put an object there and you can get it back later. One of the drawbacks of this like locator style pattern is you don't know what's in the locator, and also your like entire application gets bound by these like string names where you like look things up and pull things out. So I'm not a big fan of locators. Generalized locators, like context-specific locators are okay. Containers. So containers take the registry idea to like a generalized use case, and factories to a generalized use case. We've talked about factories that create groups of things and registries which can create and retain families of objects. And if you go down that path even further and abstract it and generalize it more, you end up at a container. And containers can create anything, but before they can do anything, you have to describe you have to give them recipes or like formulas on how to build things. So with a container, you first describe how each object gets built and what objects that object depends on. So you kind of like build the dependency recipe for the container, and then you can go to the container and say, give me, you know, the fizz knob, the fizz widget, and then it will say, oh, the fizz widget depends on the bar widget, which depends on, you know, the tacos, and it will rebuild all of those objects and say, here's your finished fizz widget. And containers let you extend or replace definitions, which is useful for testing, as you can like inject mocks, or you can replace implementations with other things. So kind of looking at a recipe for like how to use a container. So imagine the container variable is our service container, and then we can add services to it. So you can add things inside of the container. So here we're defining like, we're adding a service config, we're adding an HTTP client, and then we're adding a Stripe service, which we saw earlier. And then we'll add some dependencies. So we say that like Stripe service depends on getting the service config and the HTTP client. And then way down below, we can fetch the Stripe service out of the container, and we get the finished Stripe service with all of its dependencies. One thing to note about this container is we've defined these as add, so they're not shared. So each time we fetch a service, it'll recreate the whole object graph. If that object graph contains cycles, bad things will happen to you. So don't put cycles in these. And so kind of like now we kind of understand some of the design patterns around dependency injection. How does CakePHP work today? So CakePHP uses dependency injection, like I mentioned a couple times, mostly in registries. When you use logging or caching or helpers, all of those object types use dependency injection internally. And you're benefiting from dependency injection that the framework is cooking up for you. We have a couple like global facades or proxies, which kind of package these systems up so that you don't really need to have caching injected into your application. You can just kind of like reach to the global symbol, and then the global symbol will resolve all the dependencies for you, and then give you like a very easy to use kind of ergonomic API. So the registries all interact with configuration, and it all works beautifully. So like, what about your application logic? So registries and locators that CakePHP offers are great for handling the framework bits, but building more complex application logic, you can't always leverage the registry patterns. And oftentimes, while the registry like base classes are there, they're kind of tedious to implement and extend for your application. You may only have like one or two of a thing that you don't really need, to build registries for that specific thing. Like I wouldn't want to build a registry for a Stripe service. That's silly. So how does Cake help with like building application logic? It doesn't. Historically, we've not done anything, and you've been kind of on your own. And so that's given rise to several different solutions and like plugins that have been developed to fill this gap. And because they've been offered as plugins, they haven't maybe seen as wide of adoption as they should. And it's ended up with a lot of bespoke solutions between projects and between plugins, and not a lot of consistency. And so as a conventions over configuration-based framework, it's not an ideal place. We wanted to provide some better conventions and some better tools around containers, and make it predictable and consistent so that you can use it across your projects and across your plugins. Yeah, and we've heard your feedback that it would be nice to have a dependency injection container in the framework. So in 4.2, that's what will happen. To kind of help you build more ambitious applications, we're going to provide some better APIs to build application services and have those injected into your application's controllers and your commands. So what is an application service? I've used this word a couple times, but like, what are they? And depending on your application size, you might already have something that would be classified as an application service. So you can think, when I think of application services, I think of these kinds of things. I think of a class that combines, a logic that combines multiple ORM models. So if you have a class that coordinates multiple ORM models that isn't a controller, that's a service class. If you combine, operations between a model and a remote API, that's an application service. If you like blend two remote APIs together, so you're blending like Stripe and GitHub, or like Stripe and Google Maps, that's an application service. All of those things are application services. And if you like combine application services together, that's an application service. So there's a whole bunch of things that fall under there that you probably already have in your code. And you've probably been hand injecting dependencies into them, or like using some of the locators that CakePHP provides. But we want to make that better. So like I said, there's a container coming in 4.2. We're going to be shipping it as an experimental feature, which I'll talk about a little bit in a bit. And we're starting with application services for a few reasons. The first is it's lower risk for us. As a framework, it provides like a set of opt-in features that you can use, and limits the like blast radius around backwards compatibility. We don't want to accidentally break it, and we want to like test the waters and figure out with your feedback, what we should do next. So application services are also the biggest gap based on like what we've heard. It's like a big opportunity for us to improve the applications. So let's kind of look at like what that is going to look like. So we start off in the application class. Here we get to use the new register method to define services. This method will be available both on your application class and your plugin classes. You'll have a register hook, much like you have a routes hook or a console hook or a middleware hook. And the framework will call this hook shortly after Bootstrap is completed. So you'll get Bootstrap and then service registration, and then your commands or your middleware will be created. This ensures that you can use services in your middleware or your commands. As you're building that command list or that middleware list, and then also like you can fetch those objects out of the container as well if you so choose. And then as your application grows, you may only need to use services in subsections of your applications. Like you may end up with like 100 or 200 services if you're building a large application. And so you can use a service container as a way to encapsulate bundles of services. So we have this idea of like service providers, which is somewhat common across dependency injection implementations. And a service provider defines a list of services. So that's that provides list right there in the middle. It says like, here are the services that I offer. And then it defines a register hook. And what will happen is until you request one of the services in the provides list, that register hook won't run. So you can defer the creation of services and basically create like lazy services through the service provider system. So at the bottom, we see like adding a service provider into the container. So this is a great tool for plugins. If only part of your application uses a plugin, the plugin could expose its services as a service provider. It lets you like define lots of services with like basically with very little cost. And then one of the other things we're going to be offering is a way to access configuration. Historically, you'd be having to define factory functions to pull configuration out of the configure global. But instead, you can use this service config, which basically is like an instance level proxy. So you can get that passed into your services, and then it gives you like a read-only access to your application's configuration data. So you can use get and check to read data out of configuration, or you can define scalar values. You can pick pieces out of configure and set them into the container as specific values, and then you can have those values added to your services. So that's enough about like what are services and how to define them. Where will the framework add your services for you? So if your services are defined in the container, Cake will inject services into controller constructors. The controller will also need to be added to the container. And then you can have them, you can have services injected into command constructors. So as the framework builds a command, it'll go through all of the dependencies for the constructor and look in the container and pull them out and add them to your commands. You can have that all hooked up for you. And then controller actions, because controllers can interact with a variety of endpoints and like a variety of options, they may need to work with different services, or only some actions may need some services. So we'll use reflection to look at the action arguments, and from there extract the dependencies based on the container and then inject them in. So what does that look like? If you had parameters to construct controllers, you could have like a billing service as a parameter, and then the container will pull it out and then add it in. And you can also use these with routing parameters. So you can have, your ID is a routing parameter, and then billing service would just be a billing service, and then billing service would get pulled out of the container and passed into your action. So one thing that's going to come up is like, how do I pass the request into my services? And my answer to that is just take the request as a parameter to your services methods. So you can pass the request in, and then you don't have to depend on the request. That's a kind of a pattern I've been using. And so I mentioned experimental features. The container will be introduced as an experimental feature, and I want to talk about that a little bit. So one of the struggles we have on the core team is when we introduce features, we have a fairly strong and consistent backwards compatibility try and give. And as soon as we introduce a feature, we instantly get bound by that backwards compatibility promise. And it's hard for us to like ship things, collect feedback, and then change, just because we try and keep our major release cycle fairly long so that you have kind of stability in what you're building on top of. So what we want to try and do is like find a better middle ground for us to be able to ship features at a more rapid rate, and then be able to change them based on your feedback without like breaking compatibility and having to roll major versions all the time, because it causes a lot of like ecosystem lag. So we've noticed that it takes a long time for all of the plugins to get up to the next major version, and if we start rotating major versions more often, then it's just going to end up fragmenting the plugin ecosystem and causing a lot of pain. So experimental features will have fewer backwards compatibility promises. So experimental features will be flagged pretty clearly in the documentation, both in the book and in the API. So you'll be able to know that, you know, this feature isn't completely stable yet, and it may change in the future. We're going to do our best not to break them, but it could happen. And so how does a feature leave experimental status? It'll go into like maybe after one minor release or two, if it doesn't really go that well, and there's a lot of feedback, we'll then stabilize the feature and take the experimental flags off, at which point it will become a stable feature and has the same backwards compatibility promises that the rest of the framework has. So we're trying out this whole experimental features idea with containers, and see how that whole experimental feature system works and how you respond to containers. And then hopefully we'll have containers stable for 4.3. Might be even 4.4 if we really got it wrong, but we hope we didn't get it too terribly wrong. And what we need from you is your help. One is like we've got a couple use cases outlined that I talked about earlier in the talk. We'll need your help in testing. We'll need your help in finding use cases that we haven't thought of. So please, if you come across those and you're using the container and you find things that we haven't thought of, which I'm certain there will be, please let us know if they're an issue, and then we'll work with you on how to get that better. Right? And that's all I have for today. I have some time for questions. There's, I think, one Q&A in chat on Hammer Factories. Yeah. Will unstable features be releases or exceptional optional packages? They'll be built into the framework, and then they'll just be just be indicated as part of the API. So the feature will have like basically documentation annotation tags. Yeah, the container is currently planned to go into the core package just because of how it interacts with console and the HTTP libraries. We needed to declare so it would be able to connect to everything. Yeah. That's all I got. I'm going to stop sharing now. And how will you enable an experimental feature? You just use it. Yeah, you just kind of start using it, and then it's enabled. The framework's going to continue like calling register hooks the whole time. Once you get up to, will there only be one container? Yes, there will only be one container, and you will not have access to it in your controllers, because then it turns into a big ass global variable, which is something I don't think we should do. I lost my screen. All right, I'm gonna go on mute now. I'll be around in Slack to answer any other questions.